Okay, just want to show you another project I've been working on to help us test PA systems. This one is actually Wi-Fi controlled. So rather than just show you the board, because it won't look very much if I did that, I'll jump straight in and demo it working. So to start out with, we've got a standard Vipedia here, little test amplifier and speaker, which is just wired to one of the audio outputs. This is the device that we're talking about, and that's powered by a USB battery. And I've just wired in 3 GPIOs here. Okay, there are 8 connections on there, but I've just wired in 3 for the time being for this test. Okay. So now, if I just bring in my mobile phone and go into the application, and there you can see I've got PAVA triggering. And there you go. These 8 triggers I've got here all represent one of these outputs and one of these corresponding LEDs. So if I press the evac, for example, there you go, that's the evac playing. If I stop that,
attention, attention,
and then it stops the trigger, obviously. If I did this one, I've got this one configured to be a security announcement.
This is a security announcement. Please ensure that your personal effects and your baggage are kept with you at all times.
So stop that. Now, if I just bring up the other camera for a second, so you can better see the board. There you go. And then when I trigger, say, the alert message here,
Will Inspector Sands please go to the station control room immediately?
Yeah, just the alert. So if you was in the comms room, you wouldn't
Will
necessarily
Inspector
hear the message in the
Sands
field.
please go to the station control room immediately?
Okay, and then this one, that's the third
This
one in.
is a security announcement. Please ensure.
And then the evac. Okay, if I trigger some of these ones, it will light the LED, but obviously there's nothing wired to it. So number 7, there you go, it's triggered, it's active, but there's nothing wired to it. Okay. Okay, let's just have a quick look at the board closer up then. It's based on this thing, which is an ESP32, which is a microcontroller, and the reason I've chosen that microcontroller over others is that this supports Wi-Fi. It also has Bluetooth. I'm not using Bluetooth for this. You could, I guess, but I wanted Wi-Fi so that when you're walking around with your mobile phone, you could be anywhere. You can get a internet signal. You know, so you've got access to the internet. You could control this basically from anywhere in the world, effectively. But the idea is you might be walking around the platform, and the comms room is, you know, might be 10-15 minutes away from where you are to get into the comms room. You don't want to have to keep travelling backwards and forwards to triggering test messages or pink noise or whatever message you want to play out through the zone you're in. So that's the reason it's Wi-Fi controlled. So for each one of these outputs here, there's 8 of them, there's a corresponding LED, as I showed you in the demo. Okay, so that obviously is that one, that is that one, the red is the first one there, and each of these Opto Isolators here, they drive 2 of these. So the ESP32 energises the Opto Isolator, and in turn the output would turn on or off for each of these. Now these can be either volt free or volt driven, and that's configured by this little jumper here. So this is a 3-position jumper. So at the moment it's set to volt free, which is the bottom 2 pins here. If I move it here, the top 2, that is in now volt driven mode, and basically you provide a separate supply voltage here. So that could be a little 9-volt battery or 12-volt battery, or you could take 24 volt from the rack or whatever you like to trigger this as volt driven. Okay, but I'll put that back to volt free for now because that's what I prefer to use. What else have we got? So you can power it via the USB that's already, you know, part of this ESP32 microcontroller board, or you can control it from an external supply here, and that will support a 9-volt supply. There's a little 5-volt regulator circuit here. Okay, so you can put in a standard 9-volt battery little on-off switch there, and that will provide supply, 5-volt supply to all of the board. There is also an LCD option here, so I'll show you that in a second. But you could connect your LCD panel here. It's a I2C, so it's serially driven display board. This little jump here will enable or disable the power to it. So, you know, if you want to save your battery power, you could just disable that jumper because you're not always in the common room looking at it anyway. So why waste energy and battery power leaving an LCD lit? And similarly, you can actually disable the LEDs with this jumper here. If you just remove that link, then none of the LEDs will illuminate. All these still work, obviously, but you just won't get the LED indications, and that's just purely to save battery power. That's the only reason for that. And these two devices here, well, they're just shift registers. So serial data effectively is sent from this device over to this one. It shifts in 8 bits, then the 9th one then goes into here, and so on. So you get, these are 8-bit shift registers. So you shift in 8 here, then it goes through to here. So it's basically 16 bits. These 8 bits are driving these, and these 8 bits are driving the LEDs. Okay. Right, so just wired in a 9-volt battery connection. So if I plug that in now, and there we go, and then flick the switch, turn it on. You see you've got the power indication on the ESP32 board there. Other than that, you don't know it's working. The little blue LED will flash now and again once it boots up. But in the meantime, let's just get my mobile going. Reload the application. There we go. There's the blue light flashing there. If I press the evac button, there you go, the evac lights comes on. Turn that off. Number 3, turn that off. With the green one, there we go. So that's working off a 9-volt supply. Just turn that off again. And what we do now is we're connecting the LCD. So these 2 pillars here, you can mount this here, so it's secure on the board, and the little lead there plugs into the onboard connection like that, and we will just get that all screwed in. Okay, so the board's now mounted on there, so it's wired underneath that little ribbon cable and securely mounted on there with standoff pillars, so it's solid on there, it's not going to come off. The only downside with the LCD is it actually does block some of the LEDs here. So if you're looking at it straight on, you can't see the last couple of LEDs on the board, but actually it doesn't matter because with the LCD on, it gives you all the indications that these LEDs do anyway, so I think it's better to leave that off. So I've actually moved that jumper to disable the LEDs because you get all of your display indications on here. So I'm just going to move the camera a bit so you can see the display. At the moment you won't see it when I power it on. Okay. All right, let's camera a bit closer for you so you can see the display. Now, it ain't going to look that good, but I can assure you here it looks absolutely fine when I power it on. It's just that the camera's so close to it. But let's just turn her on. There we go. You see it says connecting, so that's connecting to the Wi-Fi. That's my Wi-Fi in my office. And there you go, it's booted up. Now the clock it's displaying will eventually change. That's going to synchronise to an NTP server on the internet. There you go, that's now an NTP time from the internet, so it's very precise. And then these little indicators here, they are for each of the output triggers. So these are effectively the same as your LEDs. So if I'll launch the app on my phone again and turn, say, the first one on, there you go, you see that's come on. And I'll turn the last one, that's come on. And let's do the third one, there we go. And if I clear all of those, there you go, it's gone off. Okay. You can see every now and again a little asterisk comes up here, and that's in sync with the blue LED that you saw earlier. And that's just a little refresh. So if anything ever gets out of sync, if you press the buttons too quickly on your mobile and something gets missed, it thinks a state is on when it's actually off or whatever, it does a full refresh, and the default is every 10 seconds, but you can adjust that to be whatever you like. Could be 1 second, could be 100 seconds. I've just chosen 10 seconds. All right? So if it ever gets out of sync, it will automatically correct itself. But provided you don't go silly with the buttons on your mobile phone, you won't have a problem anyway. So there you go, that's it, powered by battery and using the LCD display. So how do you set the Wi-Fi? Well, this little jumper here is currently on 1 pin. Okay, but if I remove that and put it across both pins, that's effectively a Wi-Fi access point reset, if you like. And then when the system boots up, it'll detect that link is set, and it will ask you for to pick an alternative Wi-Fi setting. So just demonstrate that, I'll power cycle this now. Let's turn it off and turn it on. So it says connecting, and you can see now it says connect to access point PKAE Auto. So what does that mean? Well, if I bring up my mobile phone in a separate window here, just move that over. Okay, so it's still saying connect to PKAE Auto. So on my phone, if I go into my Wi-Fi settings, and we should see on here, there we go, we've got PKAE Auto has come up as a Wi-Fi access point, which is this device here. So if I click on that, it's connecting. There we go, it's now connected to this as an access point. If I tap on that, now I can configure the Wi-Fi setting. Okay, so if I select that, it lists all the Wi-Fis that it can see in my area. These are all basically Wi-Fi access points in my home. I will go back into my office one and quickly key in my password, which I won't show you. Okay, so that's now entered, and then we can saving credentials. Now what will happen is this will now reboot, and there we go, it's connected to PKAE Office. I don't know if you can see that, but it did connect. Yeah, it's very difficult to get the camera for you to see this properly. It's now rebooted and connected to the Wi-Fi that I just configured. Okay, so I've now removed the LCD panel, and I've got my mobile phone displaying over here on the left-hand side. That's just a little window representation of my mobile phone. I just want to go through a few things about the platform that I'm using and some of the other features with the buttons that are there and how they work. Okay, so first of all, if I go into my application here, so you notice this is called Blynk IoT. This is the Blynk Platform. It's a third-party platform, and provided you don't need all of the full-blown whistles and features, which we certainly don't for this, then the platform's absolutely free to use, and you've got their interface. They host the web service, if you like, and they give you all of the control tools to set up your screen, and then there's some libraries that you use to include in your program, which is running on this ESP32 chip here. So I've included their libraries into my own program, and using their libraries I can interact with this Blynk IO platform. Okay, so if I just launch it again on my phone and go into my PAVA triggering portal, there we go, there's our 8 triggers that we had before, and if I click on the evac button, there we go, the red LED comes on there, but also it gives me kind of a virtual red LED on my mobile phone. Now that has come on as a result of this ESP32 device acknowledging back over Wi-Fi and through the platform back to my mobile phone to tell my mobile app that yes, I've got that, thank you, and I've dealt with it. So you know when you're out on a platform that has actually been received by the board, and yeah, it should have triggered, and you should be hearing the message if that's where you triggered it to play to. So I now go through and click a few more of these, and so I had all these running. Okay. There you go, I've got them all going. Let's have that one as well. They're all triggered. Now I could go and individually turn all these off if I wanted to, or I've got a clear button here which will clear all of them. There you go, it's turned them all off, and you can see they've all gone off on the board as well. Now you remember I said that the blue LED on here will blink every sort of 10 seconds, or if you've got the LCD attached, it will show a little asterisk on the LCD, and that's just doing a sort of a mop up in case things get out of sync. They shouldn't do, because normally you're triggering something, you let it play for, I don't know, 20-30 seconds, then you turn it off. So you actually pressing the buttons not that often. There's quite a gap in between you pressing the button. But if you rapidly went through click, 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 you could get slightly out of sync. So the mop-up operation just does a complete refresh of everything and gets it back on track. And that 10-second pulse, that 10-second delay, you can actually set here. So if I put it to, I don't know, 97, that'd be every 97 seconds it will now do that refresh. Or if I put it back down to, what can I go down to? What do I allow it to go to? Yeah, you go right down to 5 seconds. So you should see that blue LED now will flash every 5 seconds rather than every 10. Okay, if I put this back up, so something in a bit bigger gap, so 78 seconds, and I noticed on here that something was out of sync and I wanted to refresh it instantly, I can just click that and that would do an instant refresh. You can see the blue LED triggers when I click on that. Okay. So what about power then? If I run this off this 9-volt battery I've got here beyond my phone, let's just turn my phone display off. Well, I've got to run that. The last thing I want is for that to run out halfway through me doing my testing. So let's have a quick look on some load tests, see what kind of current this is drawing. We'll do a test from the battery and also from the USB supply. If it's coming from the 9-volt battery, of course it's got to go through this 5-volt regulator, and they're not very efficient, but there's very little load on this board anyway, so the efficiency factor doesn't really contribute that much. And on here, when you're connecting this 5-volt supply from your USB battery or USB adapter, there is voltage regulators on this board as well, so that these have got an efficiency factor. And then of course if you've got the LEDs running, if all of those are running, they're going to take a fair bit more. And if you've got the LCD running, which has got a backlight, that will take even more again. So it'll all depend on whether you've got this jumper linked or that jumper linked or the LCD connected or not. All right, so let's have a quick look at that. Right, so now I've got the board basically wired in to my bench power supply, and you can see the bench power supply screen over here. Okay, so we're on this middle channel here. I'll set it to 9 volts. It's currently turned off, so if I turn the power on, so you can see it's at 9 volts or just over, and there's currently no current, and that's because the board's turned off. So I'll now turn the board on, and you should see this will tell you the current load being drawn by the board. So if I turn it on now, there you go. So it's gone up to about, yeah, peaked at sort of 134 milliamps, and let's let it settle down. 82 milliamps when it's sort of idle. It looks like when it does its refresh, it jumps up slightly. I don't know, probably average 100 milliamps. I could average it out over a period of time, but I'll say that's probably about 100 milliamps. But there's no LEDs illuminated at the moment, so let's just go into my app and turn all those on. Okay, so they're all on. Hasn't made much difference really. What we're at 87 milliamps on the meter. Just jumping up again. Yeah, so there we go, that's what we're looking at there. Not a huge difference really, quite surprising. Let's just clear all of those, see it drop down a bit. So we're sort of at 87, 88 when it's idle. Yeah. Yeah, 83 milliamps. So next what we'll do is we'll try with the LCD connected. I'll leave it turned on. And I won't mount the LCD, I'll just plug it in. In fact, I will reboot because this is a serial display. So let's turn it off and back on. And there we go. So the LCD is running. And once again, let's put all of the LEDs on. So all in an active state. There we go, they're all on, and we are looking at now 114, it was sitting at 114 milliamps when it's idle, and then it jumps up to near on 200 milliamps. Okay, so that's worst case scenario. That's with the LCD display and every output active and every LED obviously illuminated, and each LED obviously going to take a little bit of current. All right, so that's not bad. So your 9-volt battery will give you plenty of lifetime on that. We'll do the calcs in a bit. So we're looking at about, I don't know, worst case, I would say 120, 130 milliamps on average, perhaps, when with everything fully loaded. Okay. Right, same thing now, but powered from USB battery pack. So this little device here is a little USB power meter, and if I connect in, let the board boot up, there we go. So this is our normal USB connection. It's just going via this little device and tell us how much current is being drained from that USB battery. So currently, and again the LCD is connected and running, so that's all over the place in comparison, and it's definitely higher, but remember we're only on 5-volt supply here, so whereas before we was measuring the current at 9 volts. So we're on, I don't know, 120 milliamps, something like that, averaging. Yeah, this will give you an average as well. Yeah, about 120. So, and again, let's just turn all of the LEDs on. Right, so they're all active. And not a huge amount of difference. Now, actually, when these LEDs are on, the energisation to the Opto is actually off. These work in reverse, oddly enough, which I was a bit disappointed with. So when the LED is off, you've got some load going through here. It's about 3 or 4 milliamps to turn on effectively the LED inside this Opto Isolator. So I guess you've got sort of a negating effect between each of these. If the LED's on here, then it's off in here. If this is off, then it's on in here. So one sort of equates out to the other slightly. So that's probably why we're not seeing a huge difference in the current when we turn all of these on and off. So we're at 125, 130, jumps up now and again. Give it clear. And about 120. Yeah, not a huge amount of difference. Okay, that's good. So we know what sort of current draw that we are looking at. So I think a power bank like this is probably the better option on site. So you don't want to be running out of power halfway through your shift, or even better still, use a USB charging brick plugged into the mains to give you the 5 volts. But anyhow, if something like this is quite a big battery pack. This is what is it? It is 22,400 milliamp hours. So 22,400 divided by, say, the LCD is on, the LEDs are not on, but as we saw before, it didn't make a huge amount of difference. Let's say 120, 130, let's say 130 milliamps. So this is going to give you 172 hours of continuous use, so more than enough. 9-volt batteries are pretty rubbish, to be fair, because they're actually made up of lots of 1.5 cells inside here, so they don't give you a huge amount of power. I think 600 milliamp hours, I think, something like that, depending on what brand. This is a Duracell, the higher price ones, but I think perhaps using USB is probably the better option, or maybe a 9-volt power supply plugged into there rather than a 9-volt battery. Anyhow, if you did use that, I'm sure you get a whole shift out of a standard 9-volt battery, but you just don't want to take the risk when you got a whole shift to get through. Okay, just to wrap up, if you have a requirement to do testing on site, be it SPL testing, steeper testing, just wanting to play test messages, see what it sounds like, prove your routing or whatever, and you're forever going backwards and forwards to the comms room, then this solution might be a big time saver for you. You can walk around on site with your mobile phone or laptop or a tablet or whatever, anything that's got Wi-Fi connectivity. And then over the internet, you can remotely control these outputs to trigger whatever routing you've set up. Doesn't have to be a Vipedia system, could be any PA system, provided it supports volt-driven or volt-free audio routing. And you can route a stored DVA, or you could route one of your inputs that can come from a test signal on a signal generator, like an NTI meter or something. This little picture here illustrates the board layout, so we've already gone through all this, but just go over it again. These are your Opto Isolators. That's illustration of how they are assembled internally. So this is like a little LED here, so you pass current through there, that LED will energise. That will then induce a current into this Opto receiver and turn on these, I think these are MOSFETs here, and turn those on. And then current can actually flow either way here, which is not always the case with Opto Isolators. There's normally only a one-way thing because it's a diode. But these ones I bought particularly because they will allow current to flow either direction. And I needed that because in a volt-free arrangement, it needs to flow one direction, and in volt-driven, it needed to flow the other. So that's why I bought these. What else? So there's your LEDs there. This is a little resistor pack to govern the current to those LEDs. You can move this jumper to disable the LEDs, save a bit of battery power, although it didn't seem to make it much difference. This is your Wi-Fi reset, so as long as that's linked when you power up, you can then connect to the auto access point and configure this board to connect to whatever Wi-Fi device you have got on site. This is for your LCD connection if you want to use that. The jumper there allows you to enable and disable the power. These are just little test pins for engineering. That's a 5-volt isolation to and from the ESP board. Again, that's only for engineering stuff. That transistor there is actually a bit of a safeguard, really. I didn't want these shift registers to output some random state when you power on. So this is wired to the output enable pin of both these shift registers. So when you first power on, the outputs of these are actually disabled, they're off. And until such point in my code that I know that I've sent all offs, to reset these, only then do I turn the output enable back on. So the shift registers in a disabled state until I'm happy for them to come back on. And that's about it really. So yeah, hopefully it will become of use to some of you. I'm certainly going to use it on site, so I'll catch you later.